Welcome back. Now that Pydantic is installed, let's see it in action. We will define a simple data model and test how Pydantic handles various types of input, focusing on two key behaviors: successful validation and automatic type coercion, and failure handling. 1. Defining the SensorReading model. We define a simple model that inherits from base model. It requires an integer ID, a floating point temperature, and a string status. Remember, by simply using type hints, we are defining our required data structure and validation rules. Two, successful validation and coercion. First, we test with data that perfectly matches the types. This works instantly. Next, we test with data that requires type coercion. We pass strings where integers and floats are expected. Pydantic is smart. It sees 102 can be converted to an integer and 25 can be converted to a float. It performs these conversions automatically, and the resulting Pydantic object holds the correct native Python types. Three, handling invalid data. If the input data is missing a required field, or if the type cannot be coerced, Pydantic raises a validation error. This error contains a clear list of all fields that failed validation and why. This is incredibly valuable because it tells you exactly what data to fix. We must always wrap Pydantic instantiation in a try except block to safely handle external, potentially invalid data. To summarize, Pydantic ensures data integrity at the entry point of your application. Our next lecture 42.04. Use optional. See you there.